Present value of a single sum, the $1 million example. Your client wants to accrue $1 million when she retires in 40 years. How much would she need to deposit today if she could earn an 8% rate of return? We need to diagram this problem and find 4 variables so that we can solve for a 5th. Your client wants to accrue $1 million. That's going to be future value, so we'd put that as FV. When she retires in 40 years, so we have 40 periods to get to retirement. 40 would be in. How much would she need to deposit today is the magic question, right? What's the present value if we could earn 8% on that money? And that means 8% should be IYR. It does not appear the client is saving regularly or annually, so we're just going to leave payment 0 for now. If we draw it on a timeline, it becomes a little more clear. We can see that FV is $1 million. That's our goal, that's the target. We can see we have 40 periods to get there. We can earn 8% on whatever it is we invest as PV, and no payments are going into or coming out of this problem. On the calculator, we'd start by saying 40 in for 40 periods. 8 would be the interest rate. There are 0 payments. In other words, we're not adding or subtracting right now. And we would put 1 million positive for future value because in 40 years, the client would have the $1 million to spend. Now we solve for present value and we look and say, oh, if the client deposits $46,030.93 today, that would grow to $1 million in 40 years. The $46,030.93 should come up as negative because that's a deposit the client's going to make from their wallet into an account. So it leaves the wallet, it would be a negative number. And we may be thinking that 46,000, that's doable. Grow it to $1 million. Retirement isn't that scary. Alas. Food for thought that no one wants. What would the $1 million be worth in the future? In other words, what's today's dollars? What's the inflation impact on that $1 million? $1 million seems like a lot, but 40 years from now, what's the spending power of that $1 million actually going to be? So we can change the problem up a little bit. We can say, what is today's value of $1 million retirement fund in 40 years adjusted for 3.25% inflation? 3.25 is a 100-year inflation rate and pretty fair to use in this example. Well, again, we need 4 variables and we can then find the 5th using a calculator. So we would say 40 is in, right? 40 years from now. 3.25 is the inflation rate. It's going to eat away at our spending power. You would use 0 payment in any kind of inflation example, and then $1 million would be FV or future value. So the magic question becomes, what is that $1 million worth today? We can draw it on a timeline in the same way. Well, we have $1 million today, 40 years, we're going to discount that at 3.5%, and we're going to say, okay, what is the spending power of that $1 million? Let's discount it back and see. What will that $1 million be able to buy in today's dollars? So we're going to take 40 as in, and then we're using 3.5 as I, and again, that's a historical inflation rate. We're going to say 0 is payment, and then $1 million is future value. So the magic question is, what is the spending power of that $1 million? We hit present value, and we find a pretty staggering answer. $1 million 40 years from now only has the spending power of about $252,572.47 today. It means only about a quarter as much. So when we think about being a millionaire in the future, it doesn't quite mean what it means today. And that $1 million is hardly enough to get through retirement on its own.